In this lesson, you'll learn how to define the sine, cosine, and tangent ratios and use trigonometric ratios to solve right triangles. How are trigonometric ratios used in surveying? Surveyors use triangle ratios called trigonometric ratios to determine distances that cannot be measured directly. In 1852, British surveyors measured the altitude of the peak of Mount Everest at 29,002 feet using trigonometric ratios. In 1954, the official height became 29,028 feet, which was also calculated using surveying techniques. On November 11, 1999, a team using advanced technology and the Global Positioning System, GPS, satellite measured the mountain at 29,035 feet. Trigonometry is an area of mathematics that involves angles and triangles. If enough information is known about a right triangle, certain ratios can be used to find the measures of the remaining parts of the triangle. Trigonometric ratios are ratios of the measures of two sides of a right triangle. Three common trigonometric ratios are called sine, cosine, and tangent. If we have a right triangle, they normally label the angles with capital letters and the sides opposite them with lowercase letters. So side A is opposite angle A, side B, and side C. Sine of angle A is the ratio of the side opposite. Opposite means not next to, it means across from. So we normally label that A. Over the hypotenuse is the side opposite the right angle, the longest side of a triangle, a right triangle. So that we labeled C. Cosine is the ratio of the side adjacent. Adjacent is a normal English word that means next to. So the adjacent side we labeled B. Over hypotenuse again. Tangent is the ratio of the side opposite, which we labeled A, to adjacent to A, we labeled B. You could also write it symbolically as they did, labeling the sides using the endpoints B, C, A, B, and so on. I just thought this was a little bit cleaner. You may have already noticed these buttons on your calculator. Sine, cosine, and tangent on your calculator are abbreviated SIN, COS, and TAN respectively. Now we have a nice poster on the wall that helps us remember the ratios. Sine is opposite over hypotenuse, so cosine is adjacent over hypotenuse, ca, and tangent is opposite over adjacent, toa. So there we have SOHCAHTOA. Find the sine, cosine, and tangent of each acute angle of triangle DEF, round to the nearest 10,000. For angle D, sine is the ratio of the side opposite over hypotenuse. So the side opposite angle D is the 8 square root of 3 over the hypotenuse is 19. Now if you're using one of the multi-view calculators and you type that in and hit equals, you get 8 squared root of 3 over 19. You need to hit the, I call it the switch-o change-o button, the little double arrow button that's above the equals to change it to a decimal. And so as a decimal, it's approximately, and they said nearest 10,000s. So there's tenths, hundredths, thousands, and 10,000ths place it's going to round to a 3. Okay, the cosine of angle D, adjacent to angle D is 13 over the hypotenuse is still 19. And when we type that in to get a decimal, we get about 0.6842. The tangent of angle D, opposite over adjacent. Opposite D is our 8 square root of 3 over the adjacent we said was 13. And type that in to change it to a decimal, we get 1.0659. Now let's switch gears and look at the other acute angle is angle F. Starting over with sine. Opposite F is 13 and the hypotenuse is 19, and we already found that ratio. That was about 6.6842. Cosine of angle F adjacent to angle F is the 8 squared of 3 over the hypotenuse is still 19. And as a decimal, we said that was 0.7293. The tangent of angle F, opposite over adjacent, so 13 over 8 square root of 3. And this one we're going to have to type in because we haven't already, is 0.9382. And the back of the book is going to have zeros in front of those so the decimals show up better. It's probably a good idea, but it's not mathematically absolutely necessary. Find the cosine of 65 degrees, the nearest 10 thousandths. On the multi-view calculators, it's nice because you look in the upper right-hand corner, you can see a tiny DEG, means that we are in degrees. And in the older calculators, you had to type it in backwards, the way they showed it. We can actually just type in, hit the cosine button, which is right kind of in the middle of your calculator, above the 8, above the parenthesis, above the 8, and then type in 65 and hit enter. And out pops the whole thing, but they said to round to the nearest 10,000th, so there's going to be 4 places after the decimal, so it's going to be 0.4226. Now here's some of the power of trigonometry. I've got 2 sides of my right triangle. They want me to find the measure of angle B to the nearest degree. So I know the side adjacent to angle B and the hypotenuse. So looking up our definitions, the ratio of adjacent to hypotenuse is cosine. So cosine of angle B, I know my ratio is adjacent over hypotenuse. In your calculator now, to get the inverse of something, you're going to hit second cosine, because we want to find the inverse cosine, and on your screen it gives you a parenthesis, and actually it looks like COS -1, because that's our symbol for inverse, parenthesis. And then if you can use your divide bar, you can use your fraction bar, either one. So 12 divided by 20, and it's nice to close parentheses, and it spits out 53 and some change. And they said to the nearest degree, so that's going to be closest to 53. You can find the missing measures of a right triangle if you know the measure of 2 sides of a triangle or the measures of 1 side of an acute triangle. Finding all the measures of the sides of angles of a right triangle is called solving the triangle. We could say solve, but they said find all the missing measures in triangle DEF. Well, the easiest place to start is with the angle F that's missing. We know there's 180 degrees in 3 angles of a triangle, and 180 minus 90 is always going to leave 90. So all we have to do is take 90 minus 62, and we get 28 is the measure of angle F. Now we need to find, go in alphabetical order and get X next. X is adjacent to the angle we know, and we know the opposite. So the ratio of adjacent to opposite over adjacent is tangent. So tangent of 62 equals opposite over adjacent. So the part I'm solving for is in the denominator. I'm going to have to multiply both sides by x to get it out of the denominator. So to get x by itself, we're going to divide both sides by the tangent of 62 and type it in the calculator. And again, you can either use the divide key or you can use the fraction button, it doesn't matter. And I'm working off of keystrokes using the multi-view calculators that we have in the classroom. If you have an older calculator, you may have to type this in a bit backwards. And they didn't say what to round to. Yeah, it looks like they just rounded to the nearest whole number. That'll be fine. We still need to find side y. Y is the hypotenuse, and we know opposite. So the ratio of opposite to hypotenuse is sine. So sine of 62 is the ratio of the side opposite to hypotenuse. And once again, we've got the variable in the denominator, so let's multiply both sides by y. So now I have y sine of 62 equals 15. And then we're going to divide both sides by sine of 62. And we can type it in the calculator again. And once again, I got a number really close to a whole number, but not quite. So I'm going to call it approximately. It's 16.98855. That's pretty close to 17, and our units were centimeters. You can use the Pythagorean theorem to verify that the sides are the sides of a right triangle. So does 8 squared plus 15 squared equal 17 squared? We've got 64 plus 225 does in fact equal 289. So, yep. Trigonometric ratios are often used to find distances or lengths that cannot be measured directly. In these situations, you will sometimes use an angle of elevation or an angle of depression. An angle of elevation is formed by a horizontal line of sight and a line of sight above it. An angle of depression is formed by a horizontal line of sight and a line of sight below it. In the diagram, Baron is flying his model airplane 400 feet above him. An angle of depression is formed by a horizontal line of sight and the line of sight below it. Find the angles of depression at points A and B to the nearest tenth of a degree. For both of these angles, we know the side opposite and adjacent. So our ratio is going to be tangent. So tangent of A is opposite over adjacent. And when I type that in my calculator, second tangent looks like tan negative 1. And 400 divided by 400 is just 1. And I hit enter, and I get exactly 45 degrees. Now for angle B, we're still using tangent. And our opposite is still 400, but now our adjacent is going to be 530. 400 plus 130. So in the calculator, we're going to type tangent, second tangent, so it looks like tangent to the negative 1, and I'm just going to type that in, 400 divided by 530, and I hit enter, and I get approximately, well, they said to round to the nearest degree, so it's pretty close to 37 degrees. The three common trigonometric ratios are sine, cosine, and tangent. Sine is the ratio of side opposite to hypotenuse, cosine is adjacent to hypotenuse, and tangent is opposite to adjacent. So good. If we're looking for an angle measure, use the second button.